Okay everyone, I'm going to run through some things on this lab and this simulation to help answer some questions I've been getting. First of all, here's how I have it set up. I've got it set to oscillate. I have it fixed to no end, set to no end, and I turned my damping all the way down. I didn't change any of my other settings. Notice that we have the following features. We have a ruler, a horizontal and a vertical ruler, and a timer here. We also can play the simulation in regular motion, in regular time, or slowed down time. So those are all good tools to be aware of. Now let's measure some values. These are the values we have to measure for the first experiment: frequency, wavelength, time and distance, and we have to calculate speed. Today we're going to calculate speed with velocity equals distance divided by time. We're not going to use frequency times wavelength. Okay? So be aware of that. Let's get the frequency. The frequency is right here, 1.5 hertz. And I don't need to put the unit because it's already in the header. Now let's get some waves going so we can measure our wavelength. To measure the wavelength, I want to pause it. And I want at least 2 peaks or 2 troughs in my image, so I can measure the distance between the 2 peaks or 2 troughs. I'm going to choose the troughs, and the lowest point here seems to be about right there, so that's the trough. And then the next trough is about, I'm going to say about 4.2 centimeters away. So that wavelength is 4.2 centimeters. Convert it to meters and you get 0.042 meters. So that's what we need to write in our data table. Why? Why do we convert it to meters? Well, the header says it's in meters, so we don't need to put that in meters. Now, the next thing we have here is the time. We have to measure the time and the distance actually at the same time. So to measure time and distance, obviously I'll need a ruler and a timer. Now how do I measure the distance that a wave moves? Well, as you can see, the peaks move to the right and the troughs move to the right. So I just need to figure out how fast those peaks or troughs are moving. And here's how I'm going to do that. I got a peak right here at the beginning, so I have some room for it to move. I'm going to put my 0 centimeter mark right here. That's its starting point. That's its initial position. So its initial position, I'm going to choose 0 because that's the easiest way to do this. And now I want to see how far it goes in a certain amount of time. So I need to push play on my timer, and the timer doesn't move right now because time is paused. And I'm actually going to move through time frame by frame to make this easier. So I'm going to let this thing move some distance. I can choose any distance. I'm just going to let it go 2 centimeters. So I just go frame by frame until it gets to 2 centimeters. It went 2 centimeters. That's my final position, which in meters is 0.02 meters. And you can see the change in position is just going to be 0.02 meters. That's how far it went. And the time it took to go that far is 0.32 seconds, which I got from my timer right here, 0.32 seconds. So let's write those values down. 0.32 and the distance was 0.02, and now we can calculate that speed. The speed is going to be distance over time, which is going to be 0.02 meters over 0.32 seconds. And let's see what we get for our speed. 0.02 divided by 0.32 gives me 0.0625. 0.0625. So this thing is going about 6.25 centimeters per second, or 0.026625 meters per second. And again, I don't need to put my unit because it's in the header. And so there's an example of the entire first row of data. Okay, if y'all have any other questions, just shoot them my way in the discussion post or in a Canvas message, and y'all have a good day.